So as we can start currently, is there someone familiar, at least basically, from the topic? It's no problem if you're not familiar. That's why I'm here, to present it for you. So, in our presentation today we will cover what exactly is Android as an OS, because technically it's not actually an OS. What is the structure of the applications for Android, and how these applications could be exploited. Currently, all over the world, there are over 2.5 billion devices running Android. This is not only covering mobile devices, it's also covering TV stations, software for cars, vehicles in general, and etc., which are, most of them, without the phones, are running earlier versions of Android still. As here shown on the chart, these are the versions of Android 8, 7, 8, and 9, which are basically on the market. All this cluster is versions of Android from 5 and below, still running up to date. So, what exactly is Android? It's not an operating system, as I pointed out. It's an application running on Linux. This is the base concept, which is not very familiar to most of the people using this operating system. Just in general, the ways that Android could be exploited, I'm not here to tell you to switch, if you're already using Android, to switch to iPhone. Technically, iPhones could be also exploited in the same way using features of the operating system. And additionally, there was a scandal recently that they also have included mining software in them, and etc. So no, they're not safer than the Android devices. The good thing about Android devices is that based upon the open source and big community and knowledge on it, there could be very secure solutions developed on Android. But in the general case, unfortunately, this is not true. So, what exactly does an application for Android look like? The Android applications are built on the MVP model, which means Model View Presenter, which in not very a lot of technical details means that always when there is an application, there is a database connected to it, either which is locally on the device or to a remote server. There are scripts which are interacting with this data, which are in the presentation layer, as shown there, and part of them are shown on the user as an UI. Not all the procedures which are happening on the phone for a certain device are being shown to a user. Only the ones which are being selected for UI interaction. So from this part, I can tell you that technically you are not completely familiar what is going on your phone when you start an application. You are familiar only with the things which the developer has decided to show you. And of course, the great general concept for people is to be, of course, happy, social, connect to other people, and share what they like to share. This is in general, of course. Technically, the applications for Android are, as most of you probably know, packaged in an APK file, which are backed by the AAP tool, and they are generally looking like this. So if, for example, we have a Facebook application or a game, regardless, all the files which are the pictures of the game, the animations and etc. are here in these resource files. They are being compiled to machine code, or in Java in most of the cases this is bytecode. Data files are these scripts which I just pointed out, and the plain Java code. The plain Java code, when an application is being developed, are in Java files, and they're simply being parsed to smiley files after that. And as shown here, every certain Android application has main activity files, which are the Java files. They're being described in the XML file, which technically includes what exactly does the Java file need to implement the things which need to be implemented. We will also cover that in the next slides. Additionally, every application can have additional Java files and additional description files. As shown here, this is for every certain application when the developer decides to start writing an application for Android. But always this structure is covered. We always have Java files and layout files. And all the applications for Android include this structure. It cannot be passed around if we want to use the Android layer. So when we end up with an APK file, which is the package for the Android application, logically it looks like that. We have libraries, resource files, assets, and classes, which the assets and the classes are the scripts which interact in the application. The libraries are the connections to the exposed features of the operating system. The resources are, as I said earlier, the content for the certain application. And they are always pointing out to instructions which are being written in the Android manifest, and additionally in the metinf, and the resource RSAC file. And we're not going to get too much technical on that. So this is the structure of an Android operating system. Here, this is the only thing which the user sees. You don't see what is going on here at all. So we always have our applications for phone, dialer, SMS, instant messaging, browser, camera, and etc. And we're happy with that, of course. They're, of course, communicating with the frameworks or the just logical instructions which are pointed or described in them. And here is the layer. This is always when, for example, when you click an app on your application on your phone, and the application is one of these, the logic goes through these layers to reach to here. And on this layer, this is the real Android described as operating system. Here we have the libraries or the instructions which the applications are using to interact with the device. They are basically just logically separated to internal libraries which just need to do something on the phone, or the hardware abstraction layer libraries which are on this level communicating with the hardware parts of the device, or already the operating system. For example, if you want to turn on the Wi-Fi, the Bluetooth, and etc. And of course, below we have the kernel, which is the software which is directly communicating with the hardware. The drivers, the assembly code, is here in the kernel of the operating system. So as shown here, technically Android is just an application for Linux. It's not an operating system. This is why all the applications for Android are following the exact model which I just described to you. Always when a developer writes an application for Android, he is always required to follow this logic. He cannot pass around it. Any questions so far? Okay. As code, this looks like that. Okay. The details are not very shown very clearly, but I just want to point out the Android manifest file, which is included in every certain Android application. Here on these two lines, it's we have users permission, Android name, Android.permission.internet, Android.permission.camera. So this application has declarations that it will need access to the internet and the camera. And as pointed out here in the previous slide, so technically we have an application which needs to go to here to connect to the internet and to the camera. And for Android, this is just one line of code and nothing else. But as we go down the layers, these would be one lines of codes turn into instructions and the entire files on C and then to assembly, which are then passed to the kernel. Next up, here we have another example of such a file, which already shows more permissions. Basically, when a developer writes an application for Android, there is no restriction how many permissions you will put on your application. So you can put all the required permissions for Android in just one disk file, and your application would have complete access to the system. There is no manager or dispatcher or internal software for Android verifying if your application really needs this access. The only thing that you have is when you install your application and you see that your app needs access to this and this and this, but they are just only very small part of the real things which the applications have access to. For example, on the most of the branded phones which are being sold on the market, of course you can see that record our audio would mean access to the microphone. System alert window would be access to notification, access to internet, processing outgoing calls would also be shown, but these two instructions would not be shown on your phone that the applications need access to. And this is very important. Currently, here, this is an example of applications which are managers of permissions of other applications on Android. I just want to point out that if we want to use such apps which can control all the access for certain applications, our device needs to be rooted. Otherwise, we cannot see and we're not allowed to check what is going on the phone. And it needs to be rooted because when on a rooted phone, we technically have the ability to modify what is going on here and here. If our phone is not rooted, we only have access to here, because we have just access to all the programs which are installed on our phone, which are not actually programs, they're just icons for Android, which is the real application. So we cannot go out of the Android layer application. And as shown here, for example, app called X-Privacy. This is just a small list of the things which it has access to. For example, read content of SD card. Yes, this will be shown in your phone, but run at startup. This is a permission which would not be shown on your phone if you are using a non-rooted phone. There is additionally, okay, this is a check if the application is the pro version. This permission is very interesting. Disable Android permission to internet. So this application has the access to disable the permission to internet on the phone. Why is this important and why am I pointing out so much on these permissions? Basically, every developer could write an app which has required permissions to have access to all the features which the Android can provide without notifying the user. And the user would only have partial information of what is going on because of exactly the model which I showed you a bit earlier. Because of this. Because if you have an application which has access to everything on your phone, you would only have small information about it. You would not know in details if you don't have, if you haven't seen the code of really what is going on. You would not know if the app is changing information about other apps, if it's gathering data for your call logs, for your contacts, for your messages, for your pictures, and etc. Okay, ways of writing apps on earlier versions of Android. For example, the current version of Android is 9. There are a lot of devices with 8 also and 7 on the market. But when developers write the application, the approach which they use and the thing which they want to cover is the most bigger amount of people, of users, to be able to run their applications. And there continue to be a lot of applications which are being written for older versions of Android. For example, if you make an application for Android 4.4, it will run on 4.4, it will run on 5, 5.1, 6, 7, 8, 8.1, and 9 as well. If we write a native applications for 8, it is not going to work on the earlier versions of Android. And this is a compatibility chart showing on how big amount of devices on the current global scale would be compatible with our applications if we want to write it. This chart is taken from the Android Studio version of November 2019. So as you can see here, if we make an application for versions 5 or below, we will cover a very big amount of devices. If we want to make it for a bigger version of Android, we will not be able to cover. So this is sort of a double blade. Most of the developers, of course, want to cover it because of completely even marketing concepts. When you make something and you want to sell it and you want to have the people to have access to it, of course you want to cover as much people as you can. And this in general creates issues because every earlier version of Android is not that sophisticated in security. And now we continue to the more interesting part. There are other ways of modifying Android apps. So basically, when we write an app, and I will show this a bit later, we have our Android Studio, we make our application, we add our permissions, then we compile everything and pack it into APK file, and that's it, and we're ready. And when an APK file is completed, basically the code is being compiled to bytecode, as I said, and to Smalley files, and we're done to install it on our phone. But there are certain frameworks which can open this file, take the code from it, modify it again, and then put back the files into a new APK. This is where the additional permissions can be added. So if we have a completely clean app, which is nice and fine, and we use it and we're happy with it, somebody can take this APK file, can insert all the requirements that he needs, and basically turn our applications from something which is like this or this into something which is like this, adding permissions to everything that we need, and the user is not going to be notified about that. This is a chart showing the basic logic of permissions for Android. As you can see here, access to location is, and this is for an earlier version of Android. On the newer versions, there are even more accesses which are not being shown here. So, for example, if an app needs to get access to SMS, there are 4 different sub-permissions which could be used. If the developer has written just access to SMS, all the access to these would be used. But if we, for example, write a permission specifically for reading or sending SMS, this would be added to the permissions, and again, the user might not be notified because the security of the operation system would be checking if there is a requirement for accessing this library, not in specifically these sub-libraries or sub-components. The same thing is about storage, calendar, phone features. It's reading call log, writing, making phone calls, voicemails, reading phone state. This specific reading phone state, even the new versions of Android, do not show the user that an application wants access to this thing. Using a camera, reading contacts, getting accounts, accessing to location. Very interesting. Questions? Okay, so what exactly is EvilDroid? As I pointed out, EvilDroid is a framework. These are screenshots from the developer's website of the application, which show how it's used, but I'm going to return from this slide here. So EvilDroid is an application for Linux. It can also be used on Mac, Windows as well with certain configurations, which relies on a couple of other softwares. First is the Metasploit framework, which is basically a framework for acquiring connection, acquiring root privileges, and then making modification to the Linux operating system and Unix-based operating systems. Hexterm, which is just a terminal environment, Linux Dialog Manager, which is this is a tool for dispatching of the procedures which are being put into an APK file. Of course, APT, which is the APK modifier, APK decompiler, which takes the APK and makes it into, extracts the files from it and recompiles them when required for the APT tool to be able to modify them after that. And of course, just optimizer or an archiver for APK files. And using these, by the way, the EvilDroid is an open source software. This is the original link of the developer's GitHub page. Everyone can download it from there. There is also documentation how to be configured and used. So, this is a screenshot which I made yesterday. When we start EvilDroid and we select an APK file we want to modify, what it basically does is adds all these permissions here because it's not being shown very well. I'm just going to read it to you. For example, reading SMS, accessing Wi-Fi state, setting wallpaper, receiving proofs, recording audio, writing to external storage, location, internet, contacts, SMS, everything that we need to control somebody's device without the user knowing it. So we just install these permissions for access to the phone, to the applications, and then we have everything we need on that phone. All the user needs to do is just to start this application. That's it. The procedure, just shown here, is the following. As we select the APK file, we deploy the payload. We insert the instructions, which I just showed in the previous slide. Then we inject the permissions into the smaller files, which are the compiled Java files. We rebuild the APK, we put a certificate. This is a very important part.
Which type of certificates?
We can use a default certificate of the Java Key Store, but we can also use a certificate of Google Play Store developer. For example, this is where we can actually upload this APK to a Google Play Store and nobody will notice. We just need to have an active registration. We need to have the certificate which we have received from Google Play Store, and the Google Play Store will only authenticate us based on our certificate, nothing else. There is no internal check of the APK when it's being uploaded to Google Play. For example, we can take Angry Birds, very popular game. There was a scandal about it for accessing things that it should not access. And we can download and extract the APK file from the Google Play Store of the original developer RomeView. Then we can insert all the permissions we need, and we can upload again the Angry Birds APK to the Play Store. Of course, when somebody checks so first searches in Google Play Stores for Angry Birds, there is more than 1,000 applications being shown currently in the search results. And there are different versions of Angry Birds, and some of them are not from the original developer. This is exactly because everyone who gets this APK and has active registration to Google Play Store can upload it, and then the users can install it. And the installation process will start like that. This is an app which I installed yesterday on my phone. Before that, I delivered the payload to it. I got this message because my application was not from Google Play Store. This notification shows me that this application is not unknown because it's not registered from the Google Play Store. If I continue, it may damage my phone, etc. And nothing else regarding what access to what is required in this phone. I just want to point out that my phone is not rooted. It has the latest security updates of Android for October 2019, so it should be secure, right? Yeah. And I just was able to install the application without any problems. And then I just started the Evil Droid, and this is what I got. As code, it looks like that, but when you start the listener of the Evil Droid and you have connection to your phone, to the phone which you need to exploit, you have this handling request from staging tablet payload, bytes, session started, to the IP address of the phone which has connection to this to the Evil Droid. When you make an Evil Droid app, the way in which you can deploy the payload is either by selecting a connection for local network or by selecting a connection for global network. And the service which is being started on the phone is a web service, so it doesn't require at all for the user which has this application, his phone, to be in the same network. It doesn't matter. He just needs to have some sort of connection to the internet. And this is where it gets very interesting. Once I got connection to my phone, I was able to check if my device is rooted. I was able to see my ID of my device. I was able to see how many cameras I have. I was able to just show these commands here to make pictures. I was able to take screenshots. I was able to play some files. I was able to record audio. I was able to dump my call log, my contacts, my SMSs, my geolocations, and etc. Very interesting. Any questions so far? Yes?
So is it able to decompile an app that's already signed? Or?
Yes. When you decompile it, and that's already signed, I'm going to get back to this procedure here. It's not shown very good, but this is verifying signatures. So this is the step where the certificate is inserted again. Yes, then the APK file doesn't receive the original certificate because we don't have the private part of it. But if we have our certificate from the Google Play Store, this is where we put the certificate into the APK file and we upload it then to the Play Store. And everybody can install it and be happy with that. Right? That's the idea of the Play Store. Download apps. So, any questions? Different than that? Okay. So, as I see that we have more time, I can show you how this looks like in real time. I'm just going to switch the computers. So as shown here, we have our three applications I already built yesterday. Just a simple pantry app, not a big deal about it. A screen showing the yesterday, which I have here on my computer, and then I installed the backdoor in it very easily. Okay, we just need to point out some address here. What I'm doing currently is selecting the operation for installing a backdoor to an APK file. As I pointed out, okay, I'm going to start it again. So when we start, you will draw it and select the installation of backdoor. The first thing which it gets to us is the pointing out of the public address. So this is where we insert the IP of the public address of the server or computer to which the compromised phone is going to connect. This is a port to which the web servers from the phone connects to. This is the name of the APK file. And here we have a selection of what method is going to be used. Either HTTP, TCP, or HTTPS with the exact path to the scripts. In our case, we're going to select HTTPS service with this path. Then Evil Droid asks us to select an application. This is my application which I compile, which is this app here. Very clean, smooth, and nice APK file. I just press enter and it starts installing the payloads to it. A second screen pops up, and on this screen it is going to show me all the permissions which are going to be deployed to the application. First creates the signing key, then compiles the APK file. So currently the APK file is just a folder with files in it. It starts the compiling for inserting the code for the payload to the files. These are all the permissions which are being added to. Writing to external storage, receiving of SMS, internet, calling phone, camera, writing context, reading context, setting wallpaper, accessing to network states, writing call and etc. All of them are just being put for a couple of seconds. And then it shows me a message that the APK is ready and it's in this folder. And right now with the signing, I can just upload this APK file to the Play Store and that's it. And I just decided to name it like that. I can rename it, but the internal name of the application is going to be, again, continue to be the one which I decided, which was Indit BlackHat2019. And here we have our compromised APK files. Then we upload this to the Google Play Store, and that's it. And we turn our listener on the Evil Droid, which is again a very easy task. Again, we select the IP address, the port, and the type of service which the framework is going to expect to receive. And that's it. And now we have our phone. We just connect to the internet and use it to start the app. and then we will have complete access to his phone. Straightforward. Right now we are already on the part for questions, so please. Yes?
Is the right way to download all applications from Google Store only?
Not that secure.
How to check if it's secure?
Well, there are automated, there are automated tools like vulnerability scanners. There are also scanner tools in as Android applications and as Linux applications, which basically do the same thing. They decompile the APK file, then scan all the files in the folder of everything which is extracted, and tell you if there is something wrong. But in this case, you have to do that on every application. When you download an application from the Google Play Store, it gets to a folder to which you originally do not have access to. If your phone is rooted, you will have access to this folder, and you'll be able to interact and scan all the APKs in it. Is it a good practice? Well, I wouldn't say so. It doesn't matter, because Google Play only requires you to register there. They don't check the apps that you upload to them. Of course, some of the apps which are very commonly used, for example, like Facebook, YouTube, they are used by a lot of people, and they have internal procedures for checking if everything on the applications should be fine. Sticking up to most commonly used applications would be a good practice, but again, it would not help you that much, because then Google, Facebook, and other big companies will have access to your data as well. A better approach would be for you to have a rooted phone, but I'm just pointing out that yes, enough sophisticated technical knowledge is required for a person to have a rooted phone and to make the correct exact configurations to this phone in order to make it secure. Just having your phone rooted is not enough. So it doesn't matter from where you download your applications. What matters is when you download your applications, as I pointed out on the, I can just open the picture here again. Just a second. When you have your phone rooted and you have your applications and you have startup managers, mostly commonly they're called startup managers. There are also startup managers in Google Play Store which have access to the permissions which your applications use, and then you'll be able to see for every certain applications all the permissions that it uses, and you'll be able to disable them. This one is strike out, which is disabled actually. So this application has been revoked from the opportunity to have access to this permission in particular. But of course you would need to have the deep knowledge to know which permission is for what, which applications does what, which applications access whatever it does to access, and etc. Technically on a fresh installed phone with versions of Android from 5 and above, at least for a person with enough technical knowledge, takes at least 5 hours to a day to configure everything on that device. For somebody who does not have that knowledge, it takes even more time.
So the Evo Droid, does that just inject permissions in the manifest, or does it inject something else as well?
It just injects permissions in the smart files. Manifest file is a non-compiled Android file. These files are being compiled to small files. And there it injects the codes for accessing permissions. Yes.
But does it inject anything else? That's not.
Well, when you inject the access to permissions, I can get back here. As is the basic way how the Java compilers work, you always point out first which libraries you're going to use and to which you will need access to. And when you have inserted these instructions in the beginning of the rendering of the app from the phone, it doesn't matter what else you put inside. Of course, you can put shell commands, you can put whatever, but when you start the Metasploit framework, which is here, and you receive the connection from the phone, you will be also able to put these commands to the device through the console. If you want to make an automated script which doesn't require you to stay on the computer, yes, you can insert this through the evil droid as well. This is a feature of the Metasploit framework, which is a framework, as I pointed out, for acquiring root privileges and then getting access to the operating system of the Linux operating system, making modifications to the file systems, to files, and etc. More questions? Come on.
Does the user get notified when
No.
you use like camera?
No, not at all.
Does the camera turn on or something like that?
There is a feature which, if you turn on just the camera, you don't turn on first the LED light. Of course, some manufacturers try to bypass that and disable this thing, meaning that when you turn on the camera, automatically the light will be turned on. But then, as I showed, a device has at least two cameras, and when you use the front camera, you don't have a LED on it. Another trick which is being used is that the Android device always shows a preview of the picture that it takes. But when hackers do such sorts of shots, they just modify the size of the preview to be 1 pixel, and then the user doesn't see it. More questions? Come on.
So can we use this to inject like, say, Python script or other than
Anything. Everything which the Linux kernel runs will be injected through this procedure. You can insert Python scripts, PHP scripts, Bash shell code, C code, anything which the Linux kernel supports.
So basically you're talking with the Linux directly.
Yes.
Using the Android.
Yes. You skip over all the Android security features, or just a program for Linux, and you directly communicate to the kernel, and you do whatever you want. Of course, you do it through the applications of the layer of Android, but Android doesn't notify the user about that. And there is no security restriction about it.
So all these antivirus, Android apps, they basically don't work.
They are not antivirus applications because they're just things in the Android application. They can check anything which is going on inside the Android, but not completely on the phone and not completely on. I'm just gonna get back to one of my pictures.
I think the only thing will change is probably the hash of the APK if you were to take before and after, right?
No, the certificate signing is
No, I
not.
mean, if you take a hash of the actual MD5,
Okay, so what do you mean?
there are tools that I could compare them before and after.
If you do that, yes, you can do it. But if you download it directly from the Google Play Store, that would be the original APK file. So, as your question was, if you have an antivirus software for Android on a branded phone, it only checks what is going on here. It doesn't have access to check what is going on here and here. So basically, no, it doesn't do anything. It only tells you that your Android application is running good and completely continues to send your data to somebody else without you being notified. Come on.
Shell run rootkitted system.
Sorry, what?
Rootkitted system
Okay.
for phone. Do shell?
They have access to these layers and this layer as well. Rooted device is a device which has permissions for root privileges on the operating system, which is the lowest level. And of course all the levels above it. Come on guys, more questions. I'm here to enlighten you.
There is no more questions?
Okay.
Okay, let's thank you, Stoyan.